Hello, you all. This is Darrell Berry Jr. I'll be back briefly talking about proofs, the process of doing proofs in math, which I'm not a fan of, but taking a math class at the moment, several proofs are involved. So what I'll do is briefly go over the process that my professor went over with me when I asked him the process for proofs to help me prepare for this exam that we're having on Thursday of this week. So I shall go ahead and start with that. So give me one moment here. So proofs, this is the process he went over. So basically, we start with a conditional statement. Conditional statement. And that conditional statement is if hypothesis, then conclusion. If hypothesis, then conclusion. And in our conclusion, we want to use symbols and expressions to prove that. So conditional statement, hypothesis and conclusions. And the conclusion, utilizing symbols and expressions so we can solve it algebraically, which I'll get back to. So the steps. 1, we do for direct proof, assume the hypothesis. So whatever it is that the problem wants us to prove, we first assume that it's true. And then 2, use definitions, postulates, rules, etc. in the proof. So we're going to present these. To justify the proof. Right? So we started with a hypothesis that we want to go to a conclusion that's given in the problem. Then for direct proof, assume the hypothesis is true, introduce any definitions, postulates, rules, etc. that deal with the proof or deal with the concepts we're trying to prove. And now that we have the hypothesis, we have the postulates we're going to use to try to prove it, then we consider the symbols. Right? So consider these symbols. Symbols, expressions, algebraic symbols, definitions, equalities. And we want to plug in and derive the solution. This is the solution. Derived algebraically. So plug these in and derive. So then finally, after we do our algebraic work, we should get back algebraically reach the conclusion from the premise. So that would be pretty much a thus conclusion. This will be our if hypothesis. Right? So we direct proof, assume the hypothesis is true. Use definitions, postulates, rules, etc. Present these to move us in the direction of the conclusion. Algebraically manipulate the symbols, and so forth in the process. Then when we algebraically reach the conclusion, then we state thus. Another detail is to remember to always put and I'll put remember the boundaries. So for instance, if you have some proof or you have something and there's a variable that we're attaching to it, we have to define is t all real numbers, for instance. We have some vectors multiplied by these. You have to specify if it's all linear combinations or if it's linear combos. Let's say t is less than 1. So make sure you specify for every single problem or proof what the bounds is for any variables that are not directly and clearly defined in any definitions or what have you. All right, so that's the basics of proofs that I'll hopefully be able to apply this Thursday. I'll go ahead and end this proof discussion right now, and I'll be right back to start continuing through the textbook in the series I'm doing on preparing for my next exam. So stay tuned. I'll be back in a few minutes.